Hi, everyone. Welcome to this week's DeSci community call, where DeSci Labs is going to be talking about why Web3. It's a very exciting topic that has come up quite a few times, and anytime that you're integrating blockchain technology into a solution, careful consideration needs to be made. So, definitely excited to hear the team's thoughts around this and hopefully have some additional materials coming out afterwards. With that being said, a couple quick housekeeping updates. DeSci Labs will be presenting at DeSci Boston on September 18th. So we're going to be giving a 30-minute demo and then hands-on sessions for user onboarding to anyone who's interested in coming trying out the tool. So hopefully anyone who's on this call who can be in Boston will come swing by and try out the tool a little bit. Couple other things. We'll be speaking at a panel at the ACM conference the following day at MIT's Media Lab, all around decentralized science. We will be speaking at a decentralized science panel at SmartCon on the 26th. And there are a couple other conferences popping up here and there. I believe that there is a virtual one coming up in November that's hosted by Protocol Labs and ACM together, which looking to get spots at, and a couple other things here and there. There's been a lot of great conversation on the Discord all around the back end of DeSci notes and how things are being secured. So for anyone who's interested in that, definitely go take a look. Quick shout out to John and his work on the Science Commons initiative, which is now the highest DeSci funded Gitcoin grant out there for this time around. So all really proud of community members doing big things and the amazing that he's doing there. With that, John, do you have anything to add about that?
No, just thank you to everyone who's donated. We will be looking into different resources we can build for the Commons that any project can tap into. We've been building out a couple of ones we're already working on. So if anyone has any ideas, money is great. Go ahead and donate, but time is also very valuable. Feel free to come in and volunteer to help out with the organization. Everyone that works there is volunteer anyway, so you're joining some good people, that's for sure. Looking forward to DeSci Boston too. Whoever's going to be there, it's going to be so much fun.
It's going to be a blast, and feel free to reach out on Discord if you are going to be there and want to spend a little bit of time on nodes. So with that being said, the topic of, actually one quick thing, Carla or Philip, do you want to give an update on the Future of Science seminars?
Well, we're starting next week, and we have an amazing speaker lined up for Monday. So it's actually always going to be an hour before our community call once a month. And our first speaker is going to be Gustav Nielsen, who, funny enough, will actually present a paper on research objects.
Super exciting. Super excited about that. That sounds like a great start for our seminar series.
Yeah, I'm actually really excited about it too.
That'll be fantastic. Well, with that, to anyone who's interested in joining, more information will be posted on the Discord and through the DeSci Foundation's Twitter. Feel free to reach out if you have any questions. It's going to be a great talk. So with that, I think the main topic of today's conversation, HeyFlow Science, is going to be why Web3. So Chris, do you want to go ahead and kick us off?
Yeah, sure. Yeah, that's a very important topic. First of all, I think this moniker Web3 means different things for different people. And I think it's important to kind of, call out the elephant in the room. Web3 is not just about speculating on token and monkey pictures and assorted things. There's a vast apparatus of decentralized technologies that is making its mark now. So I consider typically things like IPFS and content address storage as part of Web3. I consider the idea of anchoring states on a blockchain as part of Web3. Now, there's other perspectives on this, right? And I think this is a very fluid term that's evolving. Others, probably most of you have seen the founder of Twitter came up with Web 5, right? This idea of Web 5, which essentially has is not really something you can you can differentiate fully from Web3. It also uses, state anchoring, content address storage, these types of other decentralized technologies. And I think it's important when we think about Web3 to also go back to the root conversations that people, great innovators like Juan Bene or others have been having when they presented the idea of a robustly decentralized internet. And essentially, you have great teams out there that are building the pieces for a decentralized internet that is a method not only to secure our data, but to reclaim our data from these Web2 giants that essentially own and hoard our personal data to monetize it. And there's also the argument of privacy. The argument of privacy is very important, and I think that's one of the core calling of a better stack for the internet. There was also a concept known as Web 3.0, which is the semantic web, which goes back into the past, perhaps about 10 years. This was the idea of Tim Berners-Lee. So just to make things not more nebulous than they already are, there's a lot of different definitions and a lot of different scopes. So for our specific use case here, we're going to be arguing why blockchain solves some fundamental problems and adds some very important properties to what could become a decentralized ledger of scientific record. So I think there's essentially three different angles we can take on this. One of them is about solving the so-called chronological oracle problem, and this is something Sina will tell you more about in a few minutes. Another one is about securing an immutable trace of data, an immutable provenance link, and we can do this by combining blockchain with content addressed storage. And the third one is also facilitating transactions in a transparent way on top of these research objects, right? Creating additional layers that allow flow of value between different objects and constituencies. So without further ado, we're going to dive into each of these arguments one by one. And Sina, you want to tell us about the chronological oracle problem?
Yeah, so this is basically the requirement to fulfill this would be to have a linear chronological sequencing oracle, so an entity that can allow you to know reliably, that allows you to reliably verify that A was published before B. So like data A published before data B, or some event, right? Without trusting several parties, that have various, so currently, like in the past, before this distributed ledger technology, in order for us to verify that something occurred before something else, we had to trust a third party who may actually not be right. And there was nothing for us to know that they were correct other than us trusting them. With distributed ledger technology, we actually have the ability to verify that in a way that's really increases the amount of trust that you can have in that claim that A was published before B. So this is what we're referring to when we discuss the chronological oracle problem. So this is fairly fundamental for doing stuff like data ownership, and also accruing credit. This sort of stuff, and then also, in general, previously we didn't have a solution for this before blockchain.
Yeah, and I think it's also worth mentioning that this is a hot topic in computer science. You have great teams at Microsoft and other companies that are working on implementing state anchoring protocols to essentially secure data lineages and provenance to a chronological oracle. So you could think of a blockchain as a giant clock that's running in the background as essentially a place where you can anchor data, specific data. It can be verifiable data that allow you to secure it and allow you to essentially establish ordering, right? So that is the first the first important property of blockchain. The second one I would say is when you combine when you combine anchoring data on a blockchain and you combine this with content address storage. So what does that allow you to do? Essentially, it allows you to secure an entire data structure by just simply taking the root hash and anchoring this on chain. Now, there's different ways to do this. There's different architectures that are doing this. There's projects like Ion, like SideTree, that are more on the database side. There's projects like Ceramic. There's essentially all of these projects have this idea in common that we're going to take some states and we're going to essentially anchor those states on a blockchain. And that opens up a universe of very interesting property when it comes to establishing provenance, when it comes to data ownership, when it comes to creating immutable and tamper-proof data trails. The interesting part for our application, and this is quite specific to science, is that this architecture allows us to have permanent identifiers for any types of digital resource linked to a research object. Now, why is this important? Well, you can think of the scientific record as, a great amount of nodes that are interconnected with each other through reference lists, through essentially PIDs, which is the machine readable master key of the scientific record. And the master key right now is the DOI system, which is based on a social contract, which is essentially a lookup table, which requires a lot of maintenance, which has essentially creates these disparate artifacts where you have, let's say, DOI for your code, the DOI for your data, DOI for X and Y and Z. And at the end of the day, it's the responsibility of the publisher to put all of these together, where here we can really flip the script by creating a decentralized permanent identifier system. They're not persistent, they're permanent as long as the blockchain on which it is stored, on which these states are anchored, exists. And so that permanent identifier now allows us to link and connect components of research objects in a way that prevents link rot and content drift. Content drift is a problem. You have different forms of content drift. You have accidental content drift, where, for example, a resource has changed, right? When you make a call to an HTTP website, you essentially have no guarantees on the underlying data structure. It could change, it could vacillate. There's no immutability guarantee. But with content address storage and state anchoring, you essentially create an immutable trace where there's no content drift that's possible.
So fundamentally, the fact that we're making this choice makes everything we do have a much longer shelf life by default.
Yeah, much longer shelf life, and
theoretically infinite shelf life.
Yep, theoretically infinite shelf life, and more than that, it also creates the ability to address any subcomponent of a research object in a way that is very convenient for users. So another big part about why we would store data on blockchain is this concept of open state, right? So there's this idea that open state is the next open source, meaning that essentially if we store all the state on a blockchain, anyone can be able to listen to those states and to fetch the underlying data that corresponds to what has been stored on that contract, for example. So we're essentially creating a public API out of the box that can never be stopped. So there's no paywalls that can be erected. There's no API that can be shut off once the system really takes off. So it also creates a place of neutrality where people are secure in knowing that if they use such a system, if they create these research objects on an open state repository, nobody's going to pull the plug on the API and prevent others from building on that. Nobody's going to be able to erect a paywall because of all the information that is stored immutably is open state. That allows us to avoid vendor lock-in. We can allow users to maintain rights over their own data using public key infrastructure. We don't need to have any intermediate when it comes to the right to editing my research object, the right to adding new data, new code, a new version of my work. This can be directly owned and controlled by the authors of the work, by the scientists. We don't need any intermediary like a registration agencies to get a DOI. All of this is automatically provided by the architecture. Another part about decentralized storage now. Decentralized storage is interesting because it has essentially created a race to the bottom for storage pricing. And scientists generate humongous amounts of data, and it's difficult for them to share that data. We can be more economical with these types of crypto-economical incentives that are securing decentralized storage networks such as Filecoin or Arweave or these associated network. Because we can now create real competition for the price of storage in a way that bypasses the problem of brand. For example, Amazon will charge us, a humongous premium over their bare costs. And by creating more options for competition, we can allow cheaper ways to store large data set in a tamper-proof way that essentially provides great value to scientists that want to be sharing their large data sets with their colleagues. And another side effect of this, which is fairly interesting, is that we've showed in our product demo that we can now call these research objects by their PIDs into a line-by-line browser-based interface, but also into your IDE. So what does that mean? That means since we have a guaranteed, since we're using content address storage, which is essentially an immutable hash that allows us to address any component of a research object, that means we can start creating nodes that communicate with other nodes in a way that it doesn't break, because we have secured that data with content address storage.
I think another big thing here is that with all these different points that we've mentioned, with all these all in place, that gives you a reliable way to reference these nodes, right? These research objects, and it also makes it so that it's reasonable that something can be composed with and reused in the long term. And because of that, I believe it creates an intrinsic incentive to make sure your research artifacts are reproducible, because that is a new vector for getting cited, right? So previously, if you were to make your code reusable, the risk is that all you would get is maybe at best a pat on the back, right? And today, what we can actually do is concretely have a path for actually accruing credit for that contribution, right? So I think that's important.
Yeah, and we can imagine all sorts of application built on top of DeSci nodes that can essentially auto-calculate this credit, can auto-derive the reuse, and can accrue all of this credit to the research object so that the researchers themselves don't suffer from this problem of citation fragmentation.
Mm-hmm. And we get this, just to skip ahead a little bit, we get this question a lot about, well, how do you pick the credit algorithm? How do you pick the reputation system? How do you pick the curation algorithm? How do you pick the impact metric? Well, the best part about this is with this base infrastructure, we have the base layer to experiment with all of these concepts and see which ones actually work, right? And so this basically gives us total freedom, because we have these data kind of guarantees, these identity guarantees, this chronological ordering guarantees, this auditability guarantee, this kind of like intrinsic incentive to create reproducible artifacts. Now with all this in place, we can actually experiment and allow the markets to decide what is the best reputation algorithm that actually leads to the best outcomes, and so on.
Yeah, absolutely. And you can imagine a lot of these initiatives, funders of science participating in to essentially create and promote the reuse of scientific artifacts that are verifiable, that are stored in a data structure which is both human and machine readable, which is open state, accessible to all, it's decentralized, and that can add a lot of value to the scientific knowledge value chain.
So yeah, I think it's important that there's no single company that's controlling the scientific record. And I think it's important that we can offer our users, and users in general, the confidence that, we pretty much can guarantee that there's not going to be a paywall, right? We can pretty much guarantee that we're not going to all of a sudden shut off access to data.
Yeah, which is a classic thing. I mean, you've probably heard about the stories of Facebook and Twitter, who had these generous developer-friendly APIs. The idea was like, come, build on our stack. We're gonna help you. We're gonna create value for you. You can query our data from our APIs. And what happens is that as these networks grow and create these monstrous network effects for each other, then they have a change of mood. They essentially stop, for strategic and corporate reasons. They just stop serving these APIs, essentially rugging all of these engineers and product designers that have been building on their stack. So this is something which we cannot do with an open state architecture. We cannot do because everyone has immutable access to reading and querying the states on that ledger and the ability to go into the contents addressable storage network and to pull the underlying data. So yeah, so these are what we believe to be fairly strong reasons to secure the scientific record in such a way. I believe scientists are tired of having their work in silos, are tired of the exploitative behavior of big publishers like Elsevier, who are desperately trying now to rebrand themselves as a data analytics company because they want to own the scientific workflows and monetize those with funders and other entities, and essentially become a Facebook for science. Now, nobody wants this. People want their work to be open access, and they want their work to be outside of silos that can be shut off. So this is what we're building. And curious to take questions and to talk more about this. I'm also happy to dive into the different architectures of different projects like SideTree, like Ceramic, like DeSci nodes. All of these projects in the space have this in common, that they use blockchain to solve the chronological sequencing oracle problem. They all do it in slightly different ways. The difference between, let's say, SideTree and Ceramic versus DeSci node is that DeSci nodes is completely permissionless when it comes to creating an entry on the contract. And there's other differences as well, and I'm happy to dive into all of this and to go into technical details or to go more into the big pictures. So yeah, just fire off.
Hi.
Go for it, Bex.
Thanks. I appreciate the explanation. I love kind of this background here. I guess I wonder, is almost like, and obviously there'll always be things to do and figure out, but are you, is DeSci Labs essentially building its own competition, in that, if you create this product and then anybody can use it, I don't know. I guess I don't know exactly where this question is going, but almost are you building for your competition? Is DeSci Labs trying to set itself up in a way that future-proofing yourself, so that you'll still be able to continue and be that first mover that everyone follows? Or, are you just trying to set the standard and then let people go at it?
Yeah, so that's a great question. So I really like the way Protocol Lab has done it, where they first created a IPFS, interplanetary file system. They built a great community of open source developers, and then they created an incentive layer on top of it, right? So I think first we need to be producing out these public goods. We need to be producing out this very base layer that everyone can use. That's a rallying point. That's a neutral point of coordination, essentially. And then what needs to happen is in the space is that different players in the space, different groups in the space will be building their own layers on top of it. So you can imagine a peer review layer. You can imagine, a certification layer for badges and attributes. You can imagine a funding layer for open access for impact certificates. You can imagine all of these layers being built on top of a common point of coordination. Right. And I think that's really the goal here, is to start building out common points of coordination so that, so that we can start creating a composable stack. And I see I think this is really the way forward when it comes to modern software development. We need to be creating modular architectures, modular stack, that people can plug and play to create emergent systems with emergent properties that are greater than the sum of their parts.
Yeah, I think the other part of that question was related to like business sustainability. So obviously that is also plays a factor, right, into our kind of overall strategy. But I think when you look at it, if you don't go open source, if you don't provide these tools, it's growing increasingly common, and we've seen this that open source alternatives show up. And so it makes more business sense to actually go open source as well.
And of course, there's cost, right? There's going to be costs associated with storage. Typically, we're going to be sponsoring a lot of that. But you have to think, for the long-term sustainability, if we can get very competitive deals when it comes to large data set storage deals by using systems that rely on crypto-economic incentives that allow us to create more, essentially get more bang for our bucks, we can then, provide more services to scientists allowed to store larger data sets that get reused, that really enrich the scientific record significantly. So I saw Eric had a couple of questions. Well, difference between permanent and persistent. Well, first of all, nothing is permanent, right? I mean, in the grand scheme of things, at the end of the day, the universe dies of heat death, right? So let's just put it this way, that we call these permanent identifiers as opposed to persistent identifiers because they're stored on they essentially inherit the fault tolerance capabilities of the networks on which they're stored. So in this case, in our specific case, for now, the Ethereum blockchain. So as long as the Ethereum blockchain runs, we will have essentially this primary key that will allow us to address in a very granular way any component, code, data, video, manuscript, any component of a piece of published research. When it comes to storage, I think persistence versus permanence, there's solutions out there that are creating incentives for permanent storage. There's of course a lot of assumptions that go into these systems, and I think we need to navigate them carefully. I think the key again here is redundancy and having multiple solutions to provide the best storage guarantees possible. So while the system completely prevents content drift, right, because content drift is essentially completely eliminated from the equation by using content address storage, well, losing the underlying payload can still happen, and this is why we need to create systems that allow the storage of the underlying data at a very good cost and in a way that is as automatic as possible, essentially.
Yeah, and there's also a point to be made here around, I forget which fair point it was, but there's a fair point where if the underlying data, like a data set, has to be taken offline for whatever reason,
metadata remains.
The metadata remains. And so, perhaps there's a data set that gets put into open, the open domain that later gets removed from the open domain, for whatever reason, right? So this has happened in the past. And so in the past, it would just be gone, right? But at least now we would have a record of it existing, and we could even have metadata describing what it was and potentially how to access it if it became like a restricted data set with limited access.
Yeah. And are there examples of companies editing the scientific record in the past? Well, yeah, for sure. Publishers, for example. Elizabeth Bilk, which is one of those famous image duplication sleuth, who's responsible for more retracted papers in the history of science than anyone else. She finds essentially image manipulation in papers, and she reports them so that the papers get withdrawn. There was a famous case she shared on Twitter, where after multiple years of trying to get a paper retracted from an Elsevier journal, she finally achieved that. And then the Elsevier journal, they essentially, they scrubbed off the dates around the
pretended it didn't exist.
Yeah, pretending that that everything was done in a good timeline, right? That's convincing. So these things do happen, right? There's all sorts of
malicious content drift.
There is malicious content drift. That is definitely a thing. And can
so it would be basically impossible to achieve with our system.
Yeah,
and I think
impossible.
that's a good property, right?
Yeah, definitely. I mean, it's important because it having a fully fully verifiable trace of data is something that builds trust, and science needs to maximize trust and transparency. And that's one of the very basic North Stars under which we've been operating, and that we want to create systems that promote that. Okay, can this open state repository be created without the use of a blockchain?
You can certainly have open state repositories without the use of blockchain. You just have various. You lose certain properties of this described system, right? So you basically potentially have to trust various entities that may or may not be coordinating around the timeline of stuff being published, right? And so that all of a sudden you lose. You're basically losing, your ability to fully verify this audit trail. And so there's certainly ways of doing it, without blockchain, the open state repository. However, we haven't seen a system that does this that's working.
Yeah, and I can, there's certainly ways. I don't think so open state, yes, but permissionless and decentralized, no, I think, right? So you could also imagine essentially take the extreme example of a foundation setup that says, has in its status, it's endowed with, let's say large endowment. It has in its status that it never shuts down its API, takes care of its API, and essentially exposes all of its state inside out. Yeah. It would be possible to essentially use, strong legal guarantees and legal systems to essentially try to create such a system. So it would be possible with the laws, but it wouldn't have, essentially it would add a lot of overhead and complexity to a system which can be implemented immediately in these existing technologies, right? So the other part of that is that we would then again have intermediaries and again have, quote unquote owners of our personal data that would essentially have the master key to root access to all our data. It could do anything they want with it. So there's essentially multiple points of trade-offs. Whether you can make the answer, can you design a foundation that has in its status, very clearly enforceable, we never shut down our APIs, this and that? Yes, that's possible. So you could call it, an open state repository, because it's guaranteed by law, right? It's guaranteed at gunpoint that this is how it has to stay. But what we're doing here is we don't need a gun. We don't need the law to guarantee it, because it is this way due to the underlying technology. And that is the main difference, I would say, with that example.
It's math.
It's cryptography.
It's math instead of weapons.
Yeah, I have kind of a big picture question. Can you hear me?
Yeah, go for it.
Okay. Hi. So first, thanks. That's very inspiring. So basically, if you're creating an alternative system of publishing scientific work, let's say, so I'm, for example, might start a PhD soon, and so basically, faced with a choice, I can either go like a traditional route and try to find like publish my work in any journal owned by Elsevier, let's say, or let's say I can go ahead and do it via DeSci, or even if it's in some years, it doesn't matter. But like my main question is like scientific work nowadays is funded also by states. It's funded by the military. It's funded by certain parties with particular incentives. And my question is DeSci also an organization that now or in the future is ready to take on a role also, which would be kind of a political role to like point at the problems on that side and stand as an alternative? Do you have maybe also, are you maybe thinking about, I don't know, working together with people who don't only do the computer science side of stuff, but also let's say, the more political side of stuff, because eventually it might turn into this kind of problem where some researchers don't know or don't feel secure if they want to publish via a system like DeSci, or they want to stay into the traditional system. And I think if
Yeah.
you want the solution to work, there needs to be some kind of I don't know, maybe
Interoperability, yeah, absolutely. So we've always been thinking of creating the system in parallel to the existing system, and not in a way that it's directly competing.
So that means it's not an either or choice. It's not mutually exclusive. You can do both.
Exactly. So that means you can publish in the journals that your funders pay attention to, while still having your research object in DeSci, and creating an immutable link between the paper in the journal or on the preprint platform that your funder listens to your DeSci node that you control entirely, right? So we're doing this via digitally signed embeddings into the papers themselves. So we've been thinking very, very hard about how to maximize interoperability with the current system so that it's not, let's say, competing value proposition, but it's an additive value proposition. Now, from a purely user experience perspective, when I'm a scientist and I publish in a journal, it's like, oh, go get a DOI for your data, go get a DOI for your code, go do this, go do that. So you're out there, wrangling with all these different repositories and silos, trying to put everything together, if you do it at all. Most often it's like artifacts available upon request, right? That's how it works most of the time. But the UX for this is absolutely terrible. So if we can create a better user experience for scientists to be able to come back, and say, yep, my data is fair, my code has been published, I have permanent identifiers for every single component, and everything is secured in a place that is reachable through your platform. That's a compelling value proposition for existing established scientific players in the industries, for existing preprint platform, for existing communities, for existing publishers. Now, imagine you go on your preprint platform. This is where you want to be because let's say you have all the high energy physics community there. You don't want to go, publish on some alternative decentralized system and not getting the eyeballs. No, you want to get the eyeballs. You want to stay within that community loop. But what you want to do is essentially provide guarantees to your community that you're publishing and creating valuable artifacts along with your paper. And this is where this digitally signed embedding comes in. So that means you can take your paper in DeSci nodes, you can download it, you can put it on a preprint platform, you can make sure all of your community that matters for you has access to that content, and they can all be directed to the experience which allows them to address all of the components you've posted along with your scientific work.
And then these are great points. Then I also want to highlight that looking at our fair data standards, when we look at those, funders have increasingly grown more. Basically, they've increasingly created more demand out of the folks that they're funding to create reproducible artifacts and make their data fair, because it creates impact ROI. Basically that they can rest assured that when they're putting money into funding research, that this research can be accessible in the long term. So they're starting to mandate this stuff. So you're going to see that there's going to be a bit more pressure to actually show from basically whoever's taking the money to show that they are actually creating reproducible artifacts. And what if we can make it super easy to show that? Right, so that's very powerful, while also not being an either or situation. It's a parallel situation, so you can do both, publish on both traditional publishing sites and preprint platforms, but you can have this badge that shows that your data is going to last long term, and it's going to be findable, accessible, interoperable, and reusable, and so on. So
Yep, well said.
Okay, yes. I mean, no, I'm not sure about. So thanks for the clarifications. I'm I'm not sure. Let's say my points don't feel like they are thought through enough. So I might stop, or I might say, just yeah. I'm
No, I mean,
curious.
your comments are most welcome, and I'm really happy to like walk back, go back to the big picture and all these things. I think that's really useful. A lot of new people that come on these calls don't necessarily have all the context, so I mean, just keep going. Great to have you here.
So let's say, so even if what I'm saying is very simplifying, let's say researchers have they have pressure. It can be financial pressure, economic pressure because like of the availability of emails. They answer emails at 12 p.m. They are all like working like crazy. I don't know, just because like others do it, and so they think like they have to do it to get get their papers published, or someone else gets his or her paper published, etc. So this situation of like competition in modern capitalism, etc. So I'm wondering. So I tend to think that something like a system that you're building and proposing is can help in. Or I'm wondering how such a
Well,
system
the
can
key, the key, I think, is making researchers' lives easier, right? And I mean, that's true of every product and every initiative. I think there's two trends in science. One is increased bureaucracy. There's more and more bureaucracies. Scientists have to go through more and more red tape. It becomes more difficult, to run your research activities in light of all this additional bureaucracy that's creeping in. Now there's additional bureaucracy that's going to creep in with the fair data principles, with registering your data preservation plan, having all of these complex checklist items on your table is adding a large burden on top of your already important responsibilities. And so the question is, well, how can we take all of these additional bureaucratic requirements that are sprawling up in the horizon and that are not decelerating the least, and essentially create a simple experience so you can satisfy these and you can get the proof that you have satisfied these requirements. And so that's something we're very mindful of, is like we think in terms of how we can make scientists win time and present their research in a better light than they could have otherwise. So that's very important for us. We want to be very mindful of the time of scientists, and we want to give them a simple publishing experience for their artifacts, for their papers, so that they can have essentially a secure trail of all these components. They can have the guarantees, or let's say they can easily verify their research outputs in a way that satisfies these requirements, but is also seen as something that brings a positive light to what they're doing and reflects great on their research, their teams, their labs, and all these things. So that's very important for us.
Okay.
Can I add something that might help clarify this too? And it goes back to the why Web3 thing. And it's Chris, you mentioned it several times with the example of why Web3 needs to exist, because if it didn't, you could like create an open state, but it would have to be enforced by law. And there's all this bureaucracy that's creeping in. One of the main drivers of blockchain technology, one of the main things it's trying to solve is inefficiencies. So when you have a technology that's built in a blockchain, it's just going largely in many factors going to be more efficient than the other system, because you don't need people to do stuff. You have math and cryptography. So that is a huge factor when it comes to adoption. It's going to, as Chris was saying, make life easier for the people that use it. And DeSci Labs specifically works a lot on UX UI. It takes the feedback from the people who are using the nodes right now and integrates it very quickly to make the interaction with this new technology feel like the interaction with the old technology. And the metaphor here is you can think about MySpace versus Facebook. MySpace and Facebook essentially do the same thing, but Facebook made it better. It just made it easier to use. And eventually people just switched over because it's what happened. Everyone was on MySpace and then everyone was on Facebook. It's just a matter of UX.
Yeah, by the way, I watched I think you made an intro in ETH Amsterdam or something, and I must say it's pretty nice, and I was like, so UX, and because I think at the point there's like on the top right there's kind of a rotating cube or something turning. I was thinking like, man, like I feel like in a sci-fi movie, but this is happening in my real life, and my job might be using this kind of interfaces in my everyday life. And this was a nice moment there.
Wait till you see what comes out of DeSci Boston. The improvements from ETH Amsterdam are crazy.
Yeah.
Thank you for the feedback.
Thank you. Appreciate it.
Yeah.
I'll be following what you do. Yeah, pretty nice.
Great to have you. Thank you.
Yeah, so blockchain, chronological oracle problems, side tree, ceramic, this idea of creating an open state repository without having the threat of law to back it up. So there's a lot of points here, and I think it's important to keep in mind the big picture. There's a race right now. There's a particularly skillful and forward-thinking community. You should check them out. Check the people that are doing SideTree. Check those types of technologies. There's a lot of very interesting things that are being built in the space of anchoring secure data on chain. We are part of that. We're doing a simplified but permissionless version of this. So all of that is going to be very interesting to follow because these applications will keep expanding. And I think that I'm definitely very bullish on the idea that these types of approaches will hopefully flourish and allow users to recapture their personal data, to have some things like a single login for every application, to have things like the ability to reveal selectively, credentials and these types of things. So there's a lot of things into that space that are building out. They're fascinating projects with absolutely brilliant people. So yeah, I enjoin you to check these out.
All right, I will. Thanks. Yeah.
Any other questions? You can throw them in the chat if you don't want to come off mic. We got a little time to stick around. One of the things that you mentioned, Chris, that was super interesting to me is it had to do with the marketplace idea. And Sina, you were talking about this too. It just drives home the point that like so many times throughout life, you might be living through a bureaucratic system and think to yourself, oh my God, this is nonsense. I could do this so much better. And with these permissionless systems with Web3 or blockchain, whatever you want to call it, you're given the technical infrastructure to actually try and do it better. You don't need to end up competing with some of the monoliths. You can just start something and experiment with it. And if it is better, more people will eventually come through and start using it because, it makes their lives easier. It's very inspiring to see. I can't wait to see what comes out of the marketplace of all this technology.
Yeah, me too. I'm really excited for. I think we're in the spot now in history where a lot of the fundamental stack that's going to be used to build the application layer is improving at a very fast pace. And that means we're going to have more consumer applications. We're going to have new forms of UX that are going to appear. And that's going to be very interesting because up to now, these have been things that have been lagging behind. So yeah, for us, we are a user-focused community. We believe we want to be creating the simplest possible products to use for scientists so that they can make their work look great to their peers, to their communities that matter to them, to the public, while also essentially being able to race through all the bureaucratic requirements and like click off the box and just have that peace of mind that all of their data is fair, that everything is secured in a place that essentially has these tamper-proof guarantees, anchors the state on a chain, and allows them to have full control over their underlying creations. So yeah, that's what we hope to achieve, and that's what we're working towards.
One question I imagine some people are going to have is around the guarantees, all the guarantees that come with this technology. Like you're guaranteed it's secured, you're guaranteed that you're not going to have paywalls anymore, you're guaranteed X, Y, and Z. And I know they are true, but I'm wondering if maybe you could speak to that. Like how is this stuff, how can you even say that? How is it guaranteed?
Yeah, so well, the tamper-proofness is guaranteed, so that's verifiable data. So essentially, you take you take a data payload, can be anything, just a sequence of byte, whatever, and you hash it, through a hashing function, and you get a resulting hash, and there's only that specific data payload into that hashing function that will produce that specific hash. That means if there's any change in the underlying payload, the hash will change, and therefore you will know that the data has been changed and tampered with, right? So that's that's essentially this idea of content address. And content address storage is the idea that you can now use these hashes in a global namespace because the probability of collision between two hashes is extremely low. You can think of that as a global namespace. That means you can store, enormous amounts of hashes before even having this problem of potential collision arising. So that's the idea, and that's a guarantee that is very strong. Now, there's the guarantee against paywalls. Well, you could imagine you could imagine cases in which, let's say, an entity stores encrypted data and makes you pay to access that encrypted data. So that is a case that is possible. I don't think it would happen. I think the incentives are strongly against it. And any of the gateways that DeSci Labs will be making available as in its open source stack will essentially be there's not going to be any possibility to erect paywalls around this. Right? But you can imagine that you can have the underlying content that is encrypted and has conditions for decryption that can be used in a ways to erect a paywall. But when you think about it and you zoom out, you have the ability to essentially have multiple providers of this knowledge, multiple gateways, and the ones that will make the data open access, that will create these reusable artifacts, are the ones that are going to be creating the strongest network effects, the most composable science, the best DeSci nodes that will be pulling on the data, on this open source data of these other DeSci nodes to create extraordinary scientific works. So I don't see this, while it is theoretically possible to store encrypted payload on an open registry, it's not something that that I see happening. So and there was a third point you mentioned, Jay Ringo. What was it?
I do not remember.
Okay, so yeah, so these are those 2 points I wanted to address.
Yeah, so with the guarantees around around content address storage, like you were talking about, I just kind of looked it up for SHA-256, the current kind of gold standard, and the probability of two different files resolving to the or like hashing to the same hash, it's kind of tough to visualize. But imagine you had a like 0 point and then 60 zeros, 60, like 60 zeros, and then 43. So 0.0000060 zeros, and then the number 43. So this is like almost 0% chance. And this is basic. So that doesn't mean in the future SHA-256 can't, there can't be issues with it. But based on the work of the cumulative work of this cryptography community and a bunch of folks that have looked at this, the odds seem in our favor here.
That's a great way to put it. So it sounds like there's two main routes of guarantees here. There's cryptographic security on data, and then there's sort of the marketplace where this also goes to McBagg's question earlier about business models, where I could spin up one of these things that takes data from the underlying infrastructure and surfaces it behind a paywall, but that's going to not compete well against another group of people who can just spin this up freely and take data from the underlying architecture and display it freely. People will go to the free market. They'll go to the free business, and then that business that's displaying stuff freely will have a new novel business plan on how to sustain themselves. So that's another huge aspect of why blockchain. It forces us to rethink business plans and to resculpt what we do, what we provide to produce income for a business. It redefines what a business structure is. There's a whole bunch to that aspect of why Web3. So there's the cryptographic guarantee, and then there's the market guarantee. And you're right, the market guarantee is a little less fluid, or a little less strict, but it's still very, very likely that that's a guarantee.
Yeah, no, absolutely. I think that's a great way to put it. Yeah, I think at the end of the day, there's also this great facilitation of payment, right? That blockchain enables, and the transparency for following funds and the flow of money, which is total. And that's a good thing when it comes to science. That's a good thing when it comes to essentially creating a system that promotes distribution of resources to people who create knowledge. So
yeah, it's to me, when I found out that the taxpayer is participating in every single research paper no less than 3 times. In many cases, it's like the initial funding, the taxpayer is paying, and then it's actually at the article processing charge to actually publish it, the taxpayer is paying, and then to actually access it, the taxpayer will pay again. And if the taxpayer actually knew this, and it would, there should be like there should be blood on the streets, honestly. But what we instead have is basically an open access mandate because of pressure from the public. So that's slowly been building up. But in general, I feel like this is the point. The open access point is certainly one that's really close to the public, and the public can understand. And I think more and more folks have been increasingly aware of this issue. But I think if they've really understood the full scope, they would feel similar feelings to me: shock and disgust. And now we can have these the total traceability to taxpayer money. That is something that is potential here.
Yeah, that's a clear potential. And another thing is that there's going to be immense tailwind to all these solutions that are looking to create more secure access to researcher artifacts and article linked data. We've seen the OSTP memo from the White House mandating all publicly funded work to be open access by 2026. It also includes data. And there simply isn't the right infrastructures out there for that, especially when it comes to create readable, machine interoperable data. So that's something in which we absolutely hope to be able to carve a place and to prove the value of the systems we're building in that context. And I think this could really benefit the interoperability of scientific research. That could accelerate the pace of knowledge creation, could reduce the cost, and most importantly, could just make for a better scientist experience. It would be less bureaucracy and a more fluid and simple way to comply with all of these mandates, while creating work that is more spectacular, more interactive, and simply more interesting to the broader public.
Yeah, this is beautifully said. Folks, we're coming to time here. I do have one last thought. I'm going to ask Chris and Sina here before we go. But for anyone who wants to continue the conversation, or Noraf, if you're new in the community and want to dive deeper into the actual tech stack or have more questions tomorrow, put them in the Discord, any channel. The team is always around. We'll answer them as best we can. But Chris and Sina, so one of at the start here, you mentioned the data provenance and all this stuff, and then you just mentioned making science more enjoyable to produce because you don't have all the bureaucracy. I think another part of producing and with joy is collaboration and not having the fear that your work is going to get stolen. So I'm wondering if maybe you could tie those two threads together really quick on how having immutable records of when data, or even just like a preprint, or even just a note or an idea gets published, can encourage collaboration and maybe make research and production of science more fun for the people doing it.
Yeah, so I mean, there's always that big problem of getting scooped in science, right? So having that immutable timestamp is very, very important. The thing is, whole communities coordinate around which is a timestamp that matters, and if you're a physicist, it's the timestamp on archive. If you're, so it really depends on what's your coordination point. But having that on an immutable ledger that's open state is a great coordination point. The other thing is, yes, collaborative science is something that that we want to turbocharge by making it simpler to reuse the artifacts of other people that they've published. We want to make it as simple, to get a data set about a paper you like. Imagine if you could just type, in your IDE, HTTP import the persistent identifier of the work /data, and you would immediately start downloading, the CSV or whatever's the associated file with that. So that these are the types of systems that we want to build. We want to make it more fun, easier to rebuild on the works of others, and ultimately turn science into a more cooperative endeavor.
It's going to be so fun to watch. Oh, man. This stuff gets me pumped. Guys, we're out of time, though. We'll be back next Monday at noon with another community call. Eric, are you still around, or are you traveling?
Nope, I'm still around.
All right. Do we know what next week is?
I think it's probably going to be a recap of DeSci Boston, first and foremost. So for anyone who wants to be there, that'll be a huge part of it. I think myself and Sina, potentially Chris as well, may be participating in the ACM conference at that point. So possible that we don't have a community call next week. And if that is the case, I do apologize. But if so, I think it'll be a recap of a lot of the conference stuff.
Cool. So if there's nothing next week, we'll be back in 2 weeks. And we do have an onboarding call later this week for anyone who has more questions and want to chat on a mic. Any journal clubs coming up? Probably not, because of DeSci Boston.
Yeah, we pushed it back because of DeSci Boston just a little bit. So I think the next one is going to be on October 7th, the first Friday of the month. So that's going to be a lot of fun. And I encourage anyone who wants to come learn more about how people are actually using DeSci nodes to join that one. And in addition to the onboarding call tomorrow, we'll be having Coffee House starting immediately after this. So come stick around to just chat. If you have any additional questions about nodes, Coffee House is also a great place for it.
Thank you so much for organizing. Great seeing everyone today.
Thanks, guys.
Thanks, everyone.